Okay, so you have been studying linear algebra recently, and you have been studying coordinates and trig recently. So there's a formula for an area of a triangle that you learn when you're studying trig. So if this is side A, this is side B, this is side C, and then traditionally we call that angle A, angle C, angle B. The area equals A times B times C over 4R.
Okay.
Where R is what?
R is the radius of the circumscribed circle.
Yeah. Where's the other black marker? This one doesn't seem to be done. Okay, so that formula actually is like at least potentially useful.
We have a bunch of other ways of calculating the area, so we could probably find a way to match these up.
Yeah, so we can turn this formula around to say that R, I was having enough room to write here, R equals A times B times C over 4 times the area. And then pi r squared is just pi times that squared. Okay.
Okay.
Now the nice thing here is, since I already used A's, B's, and C's, I'll call this x1, y1.
Alright.
And I'll call this x2. Jeez, sorry, I'm running through the tripod. It's not super easy. x2, y2. So this is going to be side B, and all we need to do is find the square of the side of B. You have been studying this fairly recently. What is the distance from this point to this point? What do I need to do to calculate that distance in terms of the coordinates?
Well, you could use the Pythagorean theorem.
Okay.
And well, you draw in this triangle. It's maybe, since this is going over, it'd be x2 minus x1, and this would be y2 minus y1. So, and then you just square these two and then add them together.
And when you square them and add them together,
You
what
get the square of the side, and that's what we're trying to find.
Which is exactly what we're trying to find. So the interesting thing, in the last video we found a sketch of how to get the formula, and it looked like it was going to not be too hard. It's just intersections of lines and everything. But it still looked like it was going to be a mess. But actually now the top of this is hardly a mess at all. It's just x2 minus x1 squared plus y2 minus y1 squared. That's this one. And there's going to be 3 similar ones. And now we just need something in terms of the area. And if I call this x3, y3. So now I have a vector going here and a vector going here. And do you remember from linear algebra? It was about 2 months ago, and I'm kind of putting you on the spot. How do I find the area of the parallelogram spanned by 2 vectors?
Isn't it the dot product of the two?
It's not the dot product.
And it had something to do with the dot product.
Well, the dot product is magnitude A, magnitude B, cosine theta. So what's our triangle formula from trig when I know the side lengths?
It's 1/2 AP sine theta.
Yeah, so the dot product has the cosine in it. So there was another thing we studied in linear algebra that gave us it turned out to have a geometric interpretation.
I don't think it was the cross product. But it was something to get these 2 vectors, find an area with these 2 vectors.
It was the determinant.
Oh, right.
Also the cross product.
Oh.
But the determinant gives you a very easy formula for the area, actually. So it's actually, here this is amazing. What looked like it was going to be a lot of algebraic work turns out to really simplify.
Mm-hmm.
So now we're going to look at this formula on the computer.
All right.
and we're going to run some simulations and see what we get.
Alright.
Okay.